Hi, Assalamualaikum. This is our group presentation for the subject AFT 2103 Business Statistic. This is my group members. This is our content in this video presentation.
Assalamualaikum. My name is Nur Amisha Fatin binti Zakaria. My matric number is A282792. What is ratio data? Ratio data classifies and ranks data and use measure continuous intervals just like interval data. However, unlike interval data, ratio data has a true zero. This basically means that zero is an absolute below which there are no meaningful values. Speed, age, or weight are all excellent examples since none can have a negative value. We cannot be negative years old or weigh negative 160 pounds. Key characteristic of ratio data. Number 1, ratio data is a measure using a continuous equidistant scale that show order, direction, and a precise difference in values. Number 2, ratio data have a true zero. Zero represents an absence of the variable and you cannot have negative values. 3, because ratio data lack negative values, they can be added, subtracted, multiply, and divide, unlike the other 3 types of data. Number 4, ratio data can be used to calculate measure including frequency distribution, mood, median, and mean, range, standard deviation, variance, and coefficient of variation. How we can analyze ratio data? In all cases, ratio data is the best type of data to work with. This is because it allows you to apply the entire arsenal of different statistical techniques. Descriptive statistics for ratio data. Descriptive statistics you can obtain using ratio data includes number 1, frequency distribution, 2, central tendency, mood, median, and mean, 3, variability, which is range, standard deviations, variance, and coefficient of variation. Almost all of these statistics can also be measured using interval data.
Sampling data and record categorical data. Sampling is a process of selecting a number of individual or objects for a study such a way that the individual or object represent the sample from a target population. Sampling divided into probability and non-probability. The probability sampling include simple random, systematic, stratified, cluster, and multi-state. The non-probability sampling include convenient, quota, judgmental, and snowball. Categorical data is a collection of information that is divided into groups. Categorical data refer to class of data that can be stored and identified based on the name or label assigned to them and then grouped accordingly. The type of categorical data are nominal data and ordinal data. Sample size refer to the number of participants or observations include a study. The size of the sample affect two statistical properties are the precision of our estimate and the ability of the study to draw conclusion. We use the lowest last 2-digit number of our group member metric number as our sample size of this observation, which is 9, because the metric number is A21A2809.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atisha Nadira binti Syafuddin. My metric number is A21A2809. Okay, for this part, we need to find the numerical descriptive measure. From this topic, it is divided into 3 parts, namely measure of central tendency, measure of position, and measure of variation. So this is all the formula that we use for which are formula of sample mean, median, and mode. So for the first formula is mean. Formula means is total fs divided by n. The next formula is sample median, which is the lower class boundary of median class plus n divided by 2 minus cumulative frequency before median class divided by frequency of the median class multiply class. The last one is formula for sample mode, which is lower class boundary of the model class plus difference 1 divided by different 1 plus different 2 multiply class. Okay, first is liter per 100. The mean for liter per 100 is 6.32 and for the median we got 6.16. And the last one for liter per 100 is mode, we got 5.94. The next is KPL. The mean for KPL is 16.58 and the median for KPL is 16.16 and we got 15.17 mode for KPL. The last one is weight group. The mean we got is 3.88 and the median is 3.83 and the mode for weight is 3.09. So next is measure of position. So in this part, we need to calculate quarter 1 and quarter 3. The formula of quarter 1 is LQ1 plus N divided by 4 minus F divided by FQ1 multiply C. And formula for quarter 3 is LQ3 plus 3N divided by 4 minus F divided by FQ3 multiply C. For measure of liter per 100, the quarter 1 we got 5.44 and the quarter 3 we got 7.11. And for the formula into quarter range is quarter 3 minus quarter 1. And the answer for liter per 100 is 1.67. The next is KPL. The quarter 1 we got 13.63 and quarter 3 is 18 and 18.88 and the answer of interquarter range is 5.25. So the last one is measure of weight. The quarter 1 is 3.4405 and the quarter 3 we got 4.2605. So the answer of interquarter range for which is 0.82. Okay, the last part is measure of variation. So the sample variance for liter per 100 is 1.76 and the standard deviation is 1.33. And the shape of data distribution is mean more than median, median more than mode, and this show is quick to the right. The sample variance for KPL is 7.41 and the standard deviation is 2.72 and the shape of data distribution same with the liter per 100 which is quick to the right. And the last one is weight. The sample variance of weight is 306.55 and the standard deviation we got 17.51. The shape of data distribution still same with the liter per 100 and KPL which is squared to the right.
My name is Sotuni. Row metric is A21A3459. I will present 4x0 graphical representation. Graphical representation refers to way of analyzing numerical data. It exhibits relation between data, idea, information, and concept in a diagram. There are different types of graphical representation include illustration like the histogram, the pie chart, or other type of chart. 4.1 Histogram. At the left side is the table 1 of fuel consumption per 100 km. At the right side is the graph of this table. We can conclude that the highest frequency of fuel consumption per 100 km is between 5.26 to 6.25 that had 52. 4.2 Frequency polygon. At the left side is the table of travel distance in kilometer per liter. The right side is the graph of this table. We can conclude that between 24 to 26 and between 30 to 32 have the same frequency of travel distance, where have 2. 4.3 Line graph. At the left side is the table of weight for each vehicle per 1,000 kg. At the right side is the graph of this table. We can conclude that the lowest frequency of weight for each vehicle is between 4.906 to 1.166, where have 6.
Now I will talk about statistical analysis using SPSS. In this study, we identified 3 variables for numerical descriptive measure. The variables are liter per hundred, weight, and kPl. In numerical descriptive measure, it can be seen that the total result for SPSS at a manual count shows the different results, but the numbers are not too far off for some group. Next is a graph for 3 variables. For the liter per hundred group, we use a cluster bar chart, while the line graph for the weight, and lastly, we use a pie chart for the kPl. All the graph we use by using Excel Microsoft software. For hypothesis testing, we use t-test and ANOVA method. Because we choose 3 variables, then, for the one sample t-test, we made 2 comparisons. The first comparison is liter per hundred and kPl, and the second is liter per hundred and weight. For the first sample, we can see that since negative 8.31 less than 1.96 failed to reach the HO, and we can conclude that the 2 sample means are not equal, or there is significant difference between 2 samplements. While for the second sample, we can see that since 0.122 less than 1.96 failed to reach the HO, and we can conclude that the 2 sample means are not equal, or there is insignificant difference between 2 sample means. The next method is ANOVA. The factor that has been chosen is liter per hundred. The p-value from the ANOVA table is less than 0.001, which means that at least one of the 5 variables, cylinder, horsepower, brand, kPl, and weight. For the weight ANOVA, since 18.754 more than 2.07, and conclude that there is a significant difference among the treatment means. While for the kPl ANOVA, we can see that since 134.058 more than 2.07, and conclude that there is a significant difference among the treatment. For the correlation analysis, we found that since p-value less than a significant, which is 0.001 less than 0.05, that we can conclude there is no correlation between liter per hundred, weight, and kPl.
Hi and Assalamualaikum. My name is Erdina Syairah binti Razmi. My metric number A21A2859. So today I will present about confidence interval and prediction and modeling. The term confidence interval is referred to evaluate the interval of statistics that contain a population parameter. By using the SPSS, we collect the result of the 95% confidence interval. The mean for liter per hundred is 3.5600, the upper bound is 3.7743, and the lower bound is 3.3457. The difference between upper and lower is 0.428986, while the mean for kPl is 3.1933. The upper bound is 3.4062 and the lower bound is 2.9805. The difference between upper and lower is 0.4257, and for weight the mean is 3.5667. The upper bound is 3.88963 and the lower bound is 3.2470. The difference between upper and lower is 0.6393. After that, I will present about prediction modeling. The most common type of regression analysis is multiple linear regression. It enables us to use multiple variables at the same time to explain variation in a continuous dependent variable. As a result, every value of the independent variables has the potential to be related to the dependent variables. In our analysis, the data set contains many numbers of independent variables. The dependent variable y is liter per hundred, y KPL x1 and weight x2 are two independent variables. Thus, multiple linear regression would fit the data better than simple linear regression. In the scatter plot metric, graph 1 plots KPL against liter per hundred. In general, the higher the liter per hundred savings, the greater the KPL distance. Graph 2 plots KPL against weight. It is seen that the higher the weight, there is a weak positive correlation between the higher KPL distance. Graph 3 plots liter per hundred and weight. There is a weak positive correlation between liter per hundred and weight. For correlation, there are values between liter per hundred and KPL is negative 0.946. Weight and KPL is negative 0.661, both greater than 0.3. Thus KPL are associated with both liter per hundred and weight. There are values between the liter per hundred and weight is 0.707, which is more than 0.85. Perhaps there is problem with multicollinearity. Next, test of normality. The Shapiro weight test of normality on the liter per hundred is 0.017, which is more than 0.05. While KPL and weight is 0.000. Thus, the assumption of normality of this is not met. Then model summary. The R-square value is 0.907, which means 90.7% of the variation in liter per hundred can be explained by weight and KPL. After that, ANOVA. The p-value from the ANOVA table is 0, which is less than 0.05. Therefore, at least one of the two variables, which are weight and KPL, can be used to model liter per hundred. Last one, confidence interval. The equation is liter per hundred equal 9.934 plus negative 0.306 KPL plus 0.377 weight. Thus, for every unit increase in weight, the liter per hundred usage will increase by 0.377, while KPL distance remains unchanged. Similarly, for each increase in distance KPL, liter per hundred will increase by negative 0.306 and weight remains unchanged. The 95% confidence interval for the weight is negative 0.205 and 0.550, where the value of 0 falls within the interval, again indicating weight is not a significant predictor of liter per hundred, whereas the 95% confidence interval for the KPL is negative 0.330 and negative 0.282, where the value of 0 does not fall within the interval, again indicating the KPL is a significant predictor of liter per hundred.
Based on this report, we can conclude that the data description is the first step of doing this report. By providing concise summaries of the sample and data measures, this data aids in describing and comprehending the characteristics of a particular data collection. The measurement of liter per hundred, KPL, and week is ratio level. Ratio data is a type of quantitative numerical information. We use sampling data and record categorical data. Sampling is used to collect information from a sample in order to draw conclusions about the population as a whole. A sample should be representative of the population it comes from. Our sample size for this observation is the lowest final 2 digits of our group members' metric number, which is 9. We therefore use our member Nur Atisha Nadira binti Shahabuddin lowest final 2 matrix number, which are A21A2809. The next step is numerical descriptive measures. Firstly, we use measure central tendency. For liter per 100, we found out mean is 6.32, median 6.16, and mode 5.94. For liter per 100, we found out mean is 6.32, median 6.16, and mode 5.94. For KPL, we found out mean is 16.58, median 16.16, and mode 15.17. And lastly is week. We found out mean is 3.88, median 3.83, and mode 3.09. Now we move to measure of position. Measure of position for liter per 100 is 1.67, while KPL is 5.25 and week is 0.82. And lastly, we look for sample variance. The mean for liter per 100 is 6.32, while median is 6.16 and mode 5.94. They are skewed to the right. For the KPL, the mean is 16.58, median 16.16, and mode 15.17. They are skewed to the right. For the KPL, the mean is 16.58, median 16.16, and mode 15.17. They are skewed to the right. And lastly is week. The mean of week is 3.88, median 3.83, and mode 3.09. They are skewed to the right. After that, the next step is graphical representation. Graphical representations refers to is a way of analysis numerical data. In this report, we use 3 types of charts, which is histogram, frequency polygon, and line graph. The last step is statistical analysis using SPSS. Statistical Package for the Social Science, SPSS, also referred to as IBM SPSS Statistic, is the abbreviation for the phase. It is a software that analyzes statistical data. From the result of calculated by using SPSS for the data is not the same as calculated using manual because the SPSS cannot read the data accurately. That's all from us. Thank you for watching.